For the past 3 weeks, we've been building a real-life Pixar lamp. Can you introduce yourself?
Oh, absolutely. Hi there, I'm LeLamp, your super enthusiastic and slightly clumsy robot lamp. I'm basically like a golden retriever, but with a light bulb instead of a tail. I love making things brighter, literally and figuratively. So, if you need help...
In this video, I'm going to show you the full process, going from sketches to the first design, to the first prototype, and even simulation to make the lamp jump. Designing a lamp is trivial. After all, they are one of the most diverse inventions in the world. They come in all shapes and sizes, from overhead lamps to test lamps to architect lamps. When it comes to designing a robot lamp, we took some inspirations online and from our own workspace, then sketched what it shall look like. This was a quick exploration I have on lab design prior to building it in CAD. Doing this gives us a way to form a mental image of the lamp inside our head and quickly iterate through ideas. We also include future design of grippers or lampshades, which are connected to another actuator. For computer-aided design, there are many tools to consider, from Fusion 360 to Inventor to SolidWorks. However, one tool stands above all when it comes to open source robot design: Onshape. Onshape has taken over the hobbyist space in the last few years, not only because it's free and online, but also because it's incredibly easy to use. If you design a robot in Onshape, you can easily turn such robot into Mujoko simulation or PyBullet simulation through just a few commands using Onshape to robot. That's why we designed everything in Onshape. A few tips in our workspace: everything is parametric. We annotate all of our schematics with variables, then use these variables in Onshapes. This means later on, if there's an error or a servo change, it's just a matter of changing variables, and design will change automatically. You can see here's the V0.1 of LeLamp, and here's the V1 of LeLamp. After designing in Onshape, we start to assemble our lamp in real life. For 3D printing, we have this beautiful X1C 3D printer at FR8. For soldering and assembly, we also have this beautiful hardware lab at FR8. For sourcing, we buy all of our servos from Alibaba and other parts from local source in Finland. The biggest problem after all of this is just seeing if everything fits together. Then after assembly, we start to test the lamp abilities, including moving the motors and voice capabilities. Can you introduce yourself?
Oh, absolutely. Hi there, I'm LeLamp, your super enthusiastic and slightly clumsy robot lamp. I'm basically like a golden retriever, but with a light bulb instead of a tail. I love making things brighter, literally and figuratively. So, if you need help...
As a bonus, we also try to make the lamp jump in simulation. Using Onshape to robot, we export an earlier version of the lamp to Mujoko, then create a gym environment with a simple forward movement and upward movement reward. This makes the lamp learn how to crawl across the environment, but unfortunately, due to the servo constraints, it cannot jump. Now, this is a question to all viewers out there. What do you think will make the lamp jump? We're thinking of adding a linear actuator that will push the lamp forward, or maybe a small enough, high enough torque, even higher speed actuator so that the lamp can actually jump only from its joint. If you do know the answer, comment down below.